Alright, so this is a video for the 2.2 to 2.4 packet. We're going to be talking about linear functions, starting with slope and the relationships and all of that. So the first thing we're going to talk about, we've already had a brief conversation about the idea of the slope being a rate of change, rise over run. So rise over run, simply how is the graph changing vertically? In this case, we consider the vertical to be y, and compared to how it's changing horizontally. That would be our x's. So we're going to take the y2 minus y1 over x2 minus x1 to find our rate of change. That value within our linear function is what we call m. Alright, so if I look at the example that I have here, if I want to look just at the picture between the point 1, 1 and 3, 6. If I want to talk about rise over run, if I start at the point 1, 1, I have to go to the right 2 spaces and up 5 to get to the next point. So the up 5 is our rise, and our to the right 2 is our positive 2. So if we had to go, say, to the left, we would put a negative for 2. If we had to go down, we would put a negative in the y space. Algebraically, we're going to use this formula y2 minus y1 that we saw on the page previous to this to get our slope. So if I label this problem x1, y1, and x2, y2, I always do that just to keep myself organized. I know that if I have y2 minus y1, that gives me y2 is negative 1 minus y1, which is 3, over 2 minus negative 1. So negative 1 minus 3 is negative 4. 2 minus negative 1 is 2 plus 1, which is 4/3 all together. Sorry, I'm writing with a new pen, so I'm still getting used to this thing. There we go. Okay, so m is negative 4 over 3 in this case. So I would like you to try C and D after we do B here. Alright, so one more together. Again, if you need to, you label x1, y1, x2, y2. So I've got m equals 0 minus negative 9 over 5 minus 8. 0 minus negative 9 is 0 plus 9, so I get 9 over, and 5 minus 8 is negative 3. So my slope altogether is negative 3. I want you to try both of these two. Alright, so we can also, now that we've been able to find the slope, and we've talked about negative and positive and all of that with the values, we have 4 different ways our lines can show up. We can have a positive slope, which means the graph goes, rises towards the right. That gives us a positive slope. If it goes down towards the right, we have a negative slope. If we have a completely horizontal, the slope is 0. So what happens is my m becomes 0 over a number. Okay? And when you see that, you are just going to have an equation of y equals whatever that number is. There's no x's in it. A vertical means that when you find the slope, you got a number over 0. Okay, so this has the form for an equation for the line x equals a number with no y values in it. So for instance, x, this one would have been x equals negative 3. This one would have been y equals positive 3. If we're comparing 2 lines, we can look at their slopes and how they compare to each other. So parallel lines mean that they never touch. Okay, we learned that in geometry. So in order for 2 lines to never touch, they must have the same slope. Okay, and that makes sense. If we're talking about slope as a rate of change, then if, for instance, my rate of change is 6 miles per hour, if somebody is ahead of me also traveling 6 miles per hour, we will never catch each other unless one of us slows down or the other speeds up. Okay, so same idea with lines. The m values must be equal to each other. If we're perpendicular, they're going to be opposite reciprocals. So for instance, if the first slope is equal to, say, 3/2, well, in this case, negative 3/2, because I went down 3 and to the right 2 from one point to the next, then my perpendicular slope is going to be the opposite, so it'll be positive, and it'll be the reciprocal. So the opposite reciprocal is 2/3. So if I want to write or decide whether two lines are perpendicular, parallel, or neither, I'm going to compare their slopes. So I'm going to do the first two, and then you'll do the last two for next time. So I'm going to label them as M1 for line 1, X2, and I get 5/3 for the first one. So if the second line is parallel, I should get 5/3. If it's perpendicular, I should get -3/5. If I don't get either of those, then it's neither. Okay, so I do 7 minus 5 over -2 minus -4. So that gives me 2. It's not looking very promising, but let's see. -2 plus 4. So I get a slope of 1. So this one is neither. The next one, we're going to do the exact same thing. Okay, y2, 5 minus 4 over 2 minus -1. So I get 1/3. So again, if the next slope is parallel, or the two lines are parallel, I should get a slope of 1/3. If they are perpendicular, I should get a slope of -3/1, which is just -3. So let's check. 4 minus 2 over 0 minus -6. So I get 2/6, which simplifies to 1/3. We can use the symbol for parallel, just two lines like this. I would like you to try these two for next time. Alright, so next we have talking about, again, slope being a rate of change. So if we have a context here where the y value represents in dollars and x is in hours, my rate of change, my slope between these 2 points is going to be dollars per hour. So if I do 30 minus 12 over 5 minus 2, I'm going to get 6. Well, I guess I should go a little slower than that. I would get 18/3, which is 6, and in this case, dollars per hour. So this might be represent how much I make per hour at a job. Okay, so the second one I want you to try. Okay. The last thing is talking about, we're going to get into graphing and writing equations. So we have the y-intercept. If I look at this picture here, the y-intercept is the coordinate where the graph crosses the y-axis. So it is going to have the form 0, number. Okay. So in the equation, in slope-intercept form, that is the b value, because if I plug in x equals 0, I'm left with y equals b. So in order to graph an equation in this form, I need to know the point 0b, and I need to know the slope as the change in y over the change in x in order to graph. So for the first one, my y-intercept is -3. So I'm going to go 0 down and down 3. And then my slope is 2, or 2 over 1. So I'm going to go 2 in the vertical direction and 1 in the x direction. I'm going to go 1, 2, and over 1. I'm just going to keep doing it. 1, 2, over 1. 1, 2, over 1, and so on. And then we're going to pretend it's a little hard drawing straight lines with this pen on here. And there's my line. One more together. So if I plug in 0, I get out 2. So I'm going to start at 0, 2. And then I'm going to use the slope of 2 over 3 to find the next point. So 2 in the vertical direction, 3 in the horizontal. So I go up 1, 2, 1 over 1, 2, 3. And go up 1, 2, and over 3. The other thing you can do is go the opposite direction from 0, 2. If I'm going to, so I do, instead of up 2 to the right 3, I'm going to go down 2 and to the left 3. Down 2 and to the left. Whoops. This is a very sensitive pen. 1. And connect those points. I'd like you to try C. And for D, my hint to you is to solve for y first, then graph. Okay, so make it say y equals first and then graph it. All right, the other form we're going to talk about today is called standard form. Standard form is in the form ax plus by equals c. Okay, and how we're going to do this is by using the x and y intercept. So the last previous problem, this one right here, I could have done using this method because it is in standard form. So how I'm going to do that is by plugging in 0 for x, getting out the y-intercept, and then doing the same thing to get the x-intercept, but plugging in 0 for y. So if I plug in 0 for y in this one, I get 4x minus 0 equals 8. In order to make this true, x has to be equal to 2. If I do the same thing but for x, I get 4 times 0 minus y is equal to 8. To make that a true statement, I need this to be negative 8. So I'm going to plot those 2 points. So I've got 2, 0, and 0, negative 8. You only need 2 points to make a line. We're going to pretend that goes through both points and that it's straight. So again, plug in 0 for x, plug in 0 for y, and get the other value. So I want you to try this problem. Alright, so now we're getting into not graphing, not comparing for parallel, perpendicular, neither. We're getting into writing an equation. Okay, so we have 3 forms. Me personally, my favorite is this one right here. Most of the time, this is the one that I want to start with because I can easily get to the other 2. It depends on what information is given to you, though. Okay, so in this case, we have the slope is 3, and the y-intercept, or b value, is negative 4. So I can just jump straight to this. So in this case, I have y equals mx plus b. Try this one. Okay, now for the next set, I have m and a point. So I'm going to use my favorite one. Okay, so I have y minus y1, which is 2, negative 5 over 7 for m, and x minus 14 for x1. I could solve this for y. You don't have to, but you could solve this for y. If I did, I would get negative 5 over 7x plus 12. So maybe take a second and make sure that that's what you get. Okay. Then I want you to try